Hello everyone. So in this video again we have a very interesting question for you pertaining to sets and subsets. So let's take a look. Call a set S product free if there does not exist A, B, C element of S not necessarily distinct such that A into B equal to C. For example, the empty set and the set 16 to 20 are product free, whereas the sets 4 into 4, 16 and 2, 8, 16 are not product free. Find the number of product free subsets of the sets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's take a look at how we can solve this particular set. Let X be a product free subset. Now let us assume also consider that 1 is not an element of X. Okay, 1 is not an element of X. Now we will consider 4 different cases. Alright, so case 1, being both 2 and 3 not in X. So therefore the total number of possibilities in this particular case will be, so let me just draw out the numbers. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we know 1 is not an element, again 2 is not an element, 3 is not an element. So we are left with 1, 2, 3, 4, 5, 6, 7. So total number of subset cases that are available will be 2 to the power 7. That is 128 possible subsets of these cases. Okay. Let's now talk about case number 2. Case number 2. Here, what we have is that 2 is in X, but 3 is not in X. Okay. So this would simply means this 2 is in X, then therefore 4 will also not be in X because 4 will be a product of 2. Okay, 4 will also be a product of 2. So therefore what we can write is that the total number of cases here will be 1 will not be there, 2 will not be there, 4 will not be there. Okay, 3 is again available. So 1, 2, 3, 4, 5, 6. Okay, sorry, my bad. 2 is in the set, right? 2 is in the set. 1, 2, 3, 6, 7, 8, 9, 10. So 3 is not in X, 3 gone, 1 gone. Okay, so 2 is here. So if 2 is in the set, then 4 is also not in set. So which would imply 4 is not in X. Okay, so 4 is also gone. And with that said, any multiple of 2 again, 2 is a product. So therefore 8 will also be gone. Okay, so 1, 2, 3, 4, 5, 6. So remaining the total number of subsets will be 2 to the power 6. Okay. Now also there is a 1 by 4 chance that 5 and 10 are also in X. 4 chance that 5, 10 are also in X. So therefore total subsets will be 2 to the power 6 into 3 by 4, which further give 64 into 3 by 4 equal to 48. Okay, so these are our 2 cases solutions. Next up, case 3 case 3 is that 2 is not in X, 2 is not in X, but 3 is in X. Okay, so if we talk about this, what we have here would be say I have again 1, 2, 3, 4, 5, 6, 8, 9 and 10. 2 is not in X, 3 is in X, so therefore 9 will also not be in X, and again 1 is also not in X. Multiple 3, 6 will also not be in X. So 1, 2, 3, 4, 5, 6. Okay, so therefore this would mean the total number of subsets in this particular case again will be 2 to the power 6, which is 64 subset cases for case 3. And now if we talk about case number 4, so as case number 4, here 2 and 3 are both in X. So since 2 and 3 are both in X, so therefore we have 4, 6, 9, they will not be in X. Okay, so let me just draw this again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here 1's not here, 4 won't be here, 5 won't be here, 8 won't be here, 9 won't be here, 1, 2, 3, 4 and also 5. Another one will be 5. So only remain is 2, 3, 5 and 7. Okay, so total cases would be 2 to the power 4 equal to 16. Again, there is a chance equal to 1 by 4 that 5, 10 are both in X. 10 are both in X. So therefore our total subsets will be 16 into 3 by 4. So 12 cases over here. So therefore total subsets, total product free subsets will be equal to 128 plus 48 plus 64 plus 12. Give us 252 as our answer. So, which is our required total product free sets. So I hope this is clear to you, the method we have adopted. We have basically taken 4 different cases and subsequently we have taken out all the product free sets from the same. So kindly go through the video as many times as you feel comfortable towards understanding the concepts behind the same and try to solve the question on your own with the video as a reference. So with that said, we've come to the end of the video and I'm signing out. Thank you so much.